In this video, we're looking at inequalities, and we'll start off with the inequality 4 greater than 1. We can see the two dots on the number line representing 4 and 1, and we know it's greater than because if we can recall that greater than symbol like a crocodile's mouth, the crocodile wants to eat the larger piece. So 4, in this case, is larger than 1. Also on the number line, 4 is further to the right, which means it's a larger number. So let's have a look at some other examples. In this case, we've got x greater than or equal to 3. So on the number line, we place a dot on the number 3, and it's a bold dot, which means that x can be equal to 3. But we also know that x can be greater than 3, so it could be numbers like 4, 5, 6, etc. Or even 3.5 and 4.5. So to indicate all those possible numbers, what we do is we use a line extending from our dot at 3, and we use an arrow to indicate any number to the right of 3 is a number that is greater than or equal to 3. Let's have a look at our next example where we've got y, in this case less than 1, and we know it's less than because the crocodile mouth is opening up to the 1. In other words, 1 is bigger than y, or y is less than 1. So what we do in this case is we have an open circle at the number 1. Now that open circle means that we're looking for numbers that aren't equal to 1, but they're everything less than 1. In other words, to the left of them on the number line. And you can see here we've got the open circle at 1 and a line with an arrow pointing to the left of the number 1. So how do we solve things when the inequality is just a little bit more complicated? In this case, it's a nice simple one. We've got solve c plus 1 greater than 2. Well, we solve this exactly like we do with an equation. If we had c plus 1 equals 2, what we do is we'd subtract 1 from both sides, so we get c by itself, and we'd end up with the result of c equals 1. So the exact same process occurs with the inequality. So what we do is we say let's remove 1 from both sides. So c plus 1 greater than 2 becomes c is greater than 1. Now to illustrate that on the number line, we'll have an open circle at the number 1 because it can't actually equal 1, but it can be every number to the right of that. So we use a line to indicate all the numbers bigger than 1 with an arrow to indicate that it keeps going. Let's now look at a special case that we have to observe when solving inequalities. First of all, let's consider all the numbers which satisfy g greater than 1. So that could be numbers like 2, 3, 4, 4.5, etc. In fact, there's an infinite number that are greater than 1, and we've got a few of them on the number line here with the red dots. What happens if we multiply these numbers by negative 1? Well, 2 becomes negative 2, 3 becomes negative 3, etc. And we've shown those numbers here with the green dots. So basically what's happened is that in the first instance in red we've got all the numbers that are greater than 1, and then in green we're showing numbers that are actually less than negative 1 or to the left of negative 1. And the special property is this, is that if we've got an inequality, say for example g greater than 1, if we multiply both sides by a negative or divide by a negative, the inequality switches. We can see here in this illustration the greater than has become a less than, and you can also see in the number line that what we've got is like a reflection or a mirror image of the red line to the green line. It's basically flipped on the other side of the number line. So let's have a look at solving inequalities in a little bit more detail. So we've got 5 minus 3x is greater than or equal to 17. Now the way to solve this is to remove the values next to the x. And order of operations in reverse says to remove the 5 first. So we remove the 5 by subtracting it from both sides of the inequality. If we do that, we get negative 3x on the left, and 17 minus 5 is 12. So the inequality becomes negative 3x is greater than or equal to 12. Notice how the negative stays with the 3. The next step in the process is to remove the negative 3. Now when it's written right up against the x, it means multiplication. So what we have to do is divide both sides by negative 3. Now at this step, whenever we're multiplying or dividing with an inequality, we need to be careful because if it's a negative number involved, it's going to change the inequality from, in this case, a greater than or equal to a less than or equal to. So negative 3 is removed from the left-hand side because that's what happens when we divide that side by negative 3. And on the right-hand side, 12 divided by negative 3 becomes negative 4. But you'll notice that the inequality has switched to a less than or equal to. When we illustrate this solution on a number line, we'll notice that there's a bold dot at -4 because x could be equal to -4, but it's also less than -4, so that means all the numbers to the left of -4, which is shown by the line with the arrow, are also possible solutions. So the key thing to remember here is solving inequalities is exactly like solving equations, except if we're multiplying or dividing by a negative number, we must remember to change the inequality.